All right, so we're solving systems of equations. Now we're going to look at solving system of equations algebraically, and this exercise we're going to use the substitution method for solving systems of equations. So right here, we're given two equations. So I've got 5x minus 3y equals 23, and I've got 2x plus y equals 7. Now, I got different ways that I could do this. I'm just going to explain to you some of the things that I look for using this substitution method. And my first goal is to take one of these equations and isolate one of the variables so that I can then substitute that into the second equation. So maybe let me show you what I mean to get a little clearer. Now I'm looking at this equation right here. 2x plus y equals 7. That's the one that I am choosing to start with. And I want to isolate this y. And you can see here how I did this. I got 2x plus y equals 7. I moved the 2x over so I can isolate the y. And so now I've got y equals 2x. That should be plus 7. Plus 7, not equals 7. Minus 2x plus 7. Now that I've isolated the y, I can take this and substitute it back in for y in this first equation, in this equation. So I use this one to isolate the y. I isolate the y, and I plug it back in to the remaining equation, which in this case is the first equation. So here you see what I've got here. I took 5x minus 3 times, I inserted that minus 2x plus 7 equals 23. And now I'm going to solve this for x. So now I've got 5x. I'm distributing the minus 3. So that's giving me 5x plus 6x minus 21 equals 23. Now I'm going to combine like terms, and I've got 11x equals 44. So I'm adding the 6x and the 5x. I move the minus 21 over to the other side by adding it, and 21 to 23 equals 44. I'm now going to divide both sides by 11 to isolate the x, and x is equal to 4. Now, I take this value of x equals 4, and I plug it back in to the first equation that I used so that I can get a value for y. So here you can see I got the 2x plus y equals 7. I substitute in the 4. So now I've got 2 times 4 plus y equals 7. Well, 8 plus y equals 7. Subtract 8 from both sides, and y equals minus 1. And my solution set is x is equal to 4, y is equal to minus 1. Now, I should check my work. And I'm going to do that by plugging in these x and y values into both of these original equations to see if they come up with a true solution. So here, I've got 5. This is my first equation right here. I'm going to check it. So I got 5 times 4, substituting 4 for x, minus 3 times minus 1, substituting in the minus 1 for y, equals 23. 5 times 4 is 20. Minus 3 times minus 1 is 3. 20 plus 3 is 23. Well, 23 does, in fact, equal 3. And so certainly in that first equation, it works. Now I'm going to go ahead. I don't have to really do this, but I'm just going to go ahead for illustration purposes as much as anything else. I'm going to substitute it into the second equation. So that second equation is 2x plus y equals 7. Well, I substitute in the 4. I substitute in the minus 1 for y. And I got 2 times 4 minus 1 equals 7. 2 times 4 is 8. Minus 1. 7 does, in fact, equal 7. And so this solution, x is equal to 4, y is equal to minus 1, has proved to be true. Well, let's work through another one. Now here I'm given 2 linear equations. One is x minus 7y equals 11. And the second one is 5x plus 4y equals minus 23. And I'm going to choose one of them. Now, if you noticed in the previous slide, I choose the one that had a y without a coefficient. And that's one of the first things that I'm looking for in terms of how am I going to choose my first equation. And then this time I see that the x is by itself without a coefficient. So I'm going to choose to use it first. So I start off with x minus 7y equals 11. I just move the 7 over, and I come up with x is equal to 7y plus 11. Now, I'm going to substitute in for x in this second equation, the 7y plus 11. And you see I did that right here. So now I've got 5 times 7y plus 11, close parentheses, plus 4y equals minus 23. Well, I'm going to distribute the 5 against the 7y plus 11, so that gives me 35y plus 55 plus 4y equals minus 23. I'm going to combine the like terms. So I got 35y plus 4y gives me 39y. I subtract the 55 to both sides, and that gives me minus 78. I divide both sides by y, and I determine that y is equal to minus 2. Now I'm going back to the first equation right here, and I'm going to substitute in minus 2 for y into that equation. So I got x minus 7 times minus 2. There's where I substituted in the y value equals 11. X plus 14, when I distribute this minus 7 and the minus 2, x plus 14 equals 11, x equals minus 3. So I'm looking at a possible solution set of x is equal to minus 3, y is equal to minus 2. And so like I did the first time, I'm going to check my work. Okay, so I go back to the first equation. I've got x minus 7y equals 11. I substitute minus 3 in for x. I substitute minus 2 in for y. You can see I did this right here. And so I've got minus 3, and I go ahead and distribute the minus 7 and the 2. Minus 3 plus 14 equals 11. Well, I'm going to solve that. Minus 3 plus 14 does, in fact, equal 11, and 11 does equal 11. That is a true statement. Now, I'm going to go ahead here, and I'm going to substitute it again into my second equation, just because I want double proof of what's going on. So my second equation is 5x plus 4y equals minus 23. I substitute in minus 3 for x. I substitute in minus 2 for y. 5 times minus 3 equals minus 15, and 4 times minus 2 equals minus 8. All of that now equaling minus 23. Well, minus 15 minus 8 is minus 23, and minus 23, I think we could all agree, equals minus 23. So this solution set of minus 3, minus 2, x is equal to minus 3, y is equal to minus 2, is a true solution set for my systems of equations. X minus 7y equals 11, 5x plus 4y equals minus 23. Substitution method. Well, let's look at one last one before I turn you loose on your own. And here I've got two equations. I've got 6x minus 7y equals 23, and my second equation is 8x plus 4y equals 44. Now, unlike the two previous slides, I don't have any variable without a coefficient other than 1. And so I'm looking at these two, and I think that I can work best initially with this 8x plus 4y equals 44. And the reason why is I know I'm going to have to divide by something to isolate the y, and I see that that's a 4y, and 8 is a multiple of 4, and 44 is a multiple of 4. So I look up here and I got 6, 7, 23. It's just going to be too messy. Going to end up with a bunch of fractions, and I'm trying to avoid that. So I'm going to choose this one first. I'm going to isolate this for y, because I don't want to do it for x, because if I do it for x, I'm going to end up dividing by 8, and I'm going to end up with a fraction, and I don't like that. So I got 4y now minus 8x plus 44. I'm going to divide everything by 4, which is going to leave me with y equals minus 2x plus 11. So I hope you understand why I chose this equation first, and why I decided to, after choosing this equation, why I decided I'm going to isolate the y rather than the x. So I got y equals minus 2x plus 11. I'm going back up here to my first equation now, and I'm going to substitute that in for y. So I got 6x minus 7, and here's where I substitute the minus 2x plus 11 for y equals 23. Well, 6x, and I'm going to distribute this minus 7. Well, minus 7 times minus 2x is going to give me 14x, and minus 7 times 11 gives me minus 77. Now I'm going to combine like terms. Well, 6x and 14x is 20x, and when I add 77 to both sides, 77 plus 23 equals 100. And I'm going to divide both sides by 20, and I've got x is equal to 5. So I go back in here, and now I'm going to plug in 5 back to this original first equation to get a y value. So I substitute in 5 for x, going right to here. And so 8 times 5 is 40, and plus 4y equals 44. I'm going to subtract 40 from both sides. So now I've got 4y equals 4, and y is equal to 1. And so my possible solution set is 5 and 1. I'm going to check my work again. Going back to the first equation first, I substitute in 5 for x and 1 for y. Well, 6 times 5 is 30, and minus 7 times 1 is minus 7. So I got 30 minus 7 equals 23. Well, 23 equals 23. We all know that. So my solution set of 5 and 1 checks out to this equation. Now I go into this first equation here, and I'm going to do the same thing. I'm going to substitute in 5 for x, 1 for y. Well, 8 times 5 is 40. 4 times 1 is 4. 40 plus 4 equals 44, and 44 does equal 44. And so my little solution set here of 5 and 1 proves true in both equations. I have solved the system of equations algebraically with a solution set of 5 and 1 using the substitution method.